Hello everyone, today in this video we'll be discussing the first module of OS, which is comprised of two topics: operating system and its services. Okay, so in this video we'll be discussing the five topics in the operating system and three topics in the services, which are very important from exam point of view. If you watch this video till the end, you can easily score more than 80% marks in the exam. And before starting, make sure hit the like button and subscribe to my channel for more videos like this. So without wasting any more time, let's get started. The first topic is introduction to operating system. So what is an operating system basically? Operating system is an intermediary between the user and the hardware. Okay, so you are the user and this is the computer. If you want to interact with the computer, you have to pass through the operating system. It provides the access to the computer hardware, and it gives you the easy user friendly understandable functions which you can use to access the computer hardware and perform the operations. So it does the following: it makes the usage convenient, it increases the efficiency, it provides an environment for the user, and it allocates the resources which are available for us to use. Okay, next topic is the computer system structure. So what is computer system comprised of? It's comprised of four things: hardware, operating system, application, programs, and users. So when we open our phone, we will see many applications, right? So those are the applications which are system and application programs. So some of them are compiler, assembler, text editor, and so on. And all the users are using these system application programs, and the application programs in further interacts with the computer hardware via an operating system. Okay, so these are the four components of computer system structure. So make sure you know this concept very well, because it's important question from exam point of view. And this diagram is also very important. Okay, very important. Next, we have the user views versus system views. Okay, so there are four user views. Standalone is the one which is having a specific purpose, like a keyboard. So keyboard is the purpose is to give the inputs to the computer, and terminals is nothing but will be connected with a mainframe or a main server. Those type of users are called as terminals. Workstation is the normal one which we use as a computer system. We'll be having many systems which are connected to CPU and so on. And handheld are the mobile devices. So these are the four types of user views. And system views are two: resource allocator and control program. Resource allocator allocates the resources which are required for the execution of programs, and control program handles which program to run at what time. Okay, scheduling processes, all those come under the control program. Next topic we have is the computer system organization. So all of the devices are connected with each other via a bus. Okay, this is called as a bus which will connect all the other devices. So memory is connected with the CPU, disk controller, USB controller, and graphics adapter. And USB controller can have a mouse, keyboard, or a printer. Okay, so the switches on and run the bootstrap program. When we switch on the computer, it runs the bootstrap program, and in case if there is any interrupts, it will be handled using a vector table. Interrupt means error or a failure in the execution. So when that happens, what should happen is, if there is a error in our processor, it will go to IVT. IVT is the interrupt vector table. So this will have what type of error, where it should be going. Okay, like that kind of guide it is. If this is the error, this program should execute for correcting that error. So this will check which error is there, and it will go to that interrupt service routine and execute that routine, so that the error is getting solved. Also, it stores the data. The computer system stores the data, and there are various different spaces for the different categories. So whatever data we use, that is mainly stored in the main memory. Okay, but the main memory will be erased when we switch off the computer. So this has to be stored somewhere for a longer time. So that will be stored in a magnetic tapes, optical disk, and magnetic disk. These are the secondary storages which will be there for a longer amount of time. Okay, and this will have large data also. And main memory is a short data which will be storing the data which we access while the computer system is on. And registers and cache are very short and very fast amount of data which we very recently accessed. That data will be present here, so that if you want to access the same thing again, it will not go and fetch from the secondary memory, it will fetch from the cache itself. Okay, it's a temporary memory. Also, it handles the input output operations. It does in two ways: one is via the device driver and one is DMA. Okay, so what is device driver? Device driver means for each of the device we have, like the keyboard or the mouse or the screen, each is associated with a device driver. So what does device driver do is, it will keep on looking for the input and the outputs, and based on that it will process the data. But sometimes it happens that it gets blocked because of many input output going and coming back, right? So in that case, we'll be using DMA, which is the direct memory access. Okay, DMA is the direct memory access. So this is the device we have, and by using the device driver, we'll be doing these things: interrupt request and the data and the input output operation, and threads will be formed. Then that will be gone to the memory one by one, and we'll be getting back the output. So this is a tedious process and very long process. So we'll be using DMA, which will be directly interacting with the memory and getting the data. Okay. Next topic we have the computer system architecture. It's divided into three categories. Okay, the how many computer systems are there? Three categories are there. Single processor system means that it is a device specific processor. So it will just have one specific purpose like keyboard, mouse, disk, etc. That is a single processor system. Multiprocessor will have different devices connected with each other, sharing the memory, sharing the bus, and sharing the clock time. So what here happens is that we need not have a separate memory for each of them, separate bus for each of them, and separate processors for each of them. All of them will be interconnected and sharing it. Okay, so it is more advantageous. Next we have is the clustered system. It is same as multiprocessor system, but it is connected via network in different very far locations. If it's present, it's connected via network like using the WAN, MAN, or LAN. Okay. Next topic we have is the operating system structure. There are two types of operating system structure: multi-programming and multitasking. Okay, what's the difference? Multi-programming will be having a different task assigned one after the other. So when one gets completed, it will go to the next. But it's not always that if one gets completed, then only it will go to the next. For example, if this is waiting for the input output something operation, at that time when it is waiting, it will go to the second program and execute this one, and when the input output is ready, it will come back and execute the input output program. Okay, so that is called as multi-programming. Multitasking is the time sharing, means each of these program will be sharing equal amount of time, and very fast it will keep on switching, so that we will feel everything is happening parallelly, but actually it's happening at the a very faster pace, so we don't understand it that it's also happening one by one, but it's very fast. Okay, and it shares the time, 2 seconds here, 2 seconds here, 2 seconds here. It's actually very small, like 2 nanoseconds or 2 milliseconds. Okay. Next topic we have is the operating system operations. What are the different operations present? So we have a dual mode operation. What is dual mode? Dual means two modes. Which are two modes? Kernel and the user. As we know, the users are we, and the kernel is the inner system, right? So when we are doing any execution, we cannot directly access the kernel. Okay, that is not allowed for the normal user. It is only allowed for the super user or the root user. So normal user, when it's executing, it will call the function which will do the operation and give back the result. You got it? It will call some function, system call. It will go here and it will do the execution and will get back here. So when it is present here, it is called the user mode, and it is defined by a mode bit. When it is 1 means user mode, and when it goes to the kernel, the user mode I mean the mode bit becomes 0, which denotes that it is in the kernel mode. Okay, and we cannot have any control over the kernel mode. It runs automatically, and user mode will be using generally. Okay. Next topic we have is the management types. There are three different types of management: process management, memory management, and storage management. Process is nothing but whatever the functions we perform, how it is to be performed, when it is to be performed, how much memory is to be allocated. All those handling and management process management things are done by process management. And next we have the is the memory management. Like suppose we'll be using some memory initially, and when our task is done, still that memory will be occupied, but there should be a mechanism to identify this task is over and clear of this memory, right? So that is done by memory management. And the third one is storage management. It comprises of three things: file system, mass storage, and cache. Clearing the files, deleting, creating, modifying the files is called as file system storage management. Mass storage is the other ones which are the inner storages stored in bits and bytes. Managing that is called mass storage. Cache is the temporary memory. If it is not more required, it should be replaced with the latest ones, right? So that management is called as storage management. Next, we have protection and security. What do you mean by protection? It is a mechanism for controlling the access of processors or users. It will control the process and the users from accessing the resources of the computer. Only the ones who has the access, they can only use the resources. Okay, that is called as a protection. And most of the system use usernames and user IDs and passwords for implementing the protection and security. So it has its own advantages, which we all are aware of. Next we have is the system types. There are two types of systems: distributed system and special purpose systems. Distributed system will have different kinds of systems in different places, and all will be interconnected via network. That is called as distributed system. And the advantage here is that if one of the system fails, it does not matter, because rest of the system will handle it. Next, we have this special purpose system. Here we'll have two types, multimedia and handheld. This includes the videos and audios and images, and this includes our personal device. Moving on, we have the next topic, which is the computing environments. What do you mean by computing environments? There are different kinds of environments using which we can do the computation, and for different purposes. Okay, so let's have a look at the different computing environments. So we have four main types of computing environments. Traditional computing, which includes uh, private computer, which includes the CPU, keyboard, mouse, and everything what is required in a local area. Okay, so that is called as a traditional computing. Next we have is the client server computing. So there will be a server present, and via cloud all the clients will be connected. This is called as a client server computing. Peer-to-peer computing means the different clients will be connected, interconnected with each other, and share the file and resources and process and the memory and everything. They will be intersharing with each other. That is called peer-to-peer computing. And the last one is web-based computing. By using a network, we'll be sharing the resources in different locations. That is called as web-based computing. Moving to the second half of the module, the first topic is operating system services. What are the different services provided by the operating system? So this diagram is very important. Start from the top here. So here what we have, user and other system program. These are the general programs which we use. Those are called as user and other system programs. Next we have the GUI, means graphical user interface. We'll be having an icons which you can click and do the operations, right? And the batch operations are nothing but a set of operations which will be running internally. And command line is the CMD, right? You are aware of CMD, where we'll be executing the commands by typing the keywords. And these are the different types of user interfaces. It provides different types of user interface. Via these three things we can access the kernel and its operations. Next we have the system calls. So each of these will be internally calling the system for performing the operations. Let's have a look. Program execution. If you want to run some program, we'll be using the program execution for running it. If you have to provide some input and the output, we'll be using IO operations. If it's related to files, we'll be using file system for creation, deletion, updation of the files. Communication with the different processes and the resources, allocating the resources for each process. Accounting, how many resources are there, how many memory is left, what is the speed of CPU, what's the performance, all these things. Error detection, if there is any error in the transformation of the data or any process being executed, that will be detected. And protection and security, only the ones which has the privilege to access the resources should be given the access. That check is called protection and security. So these are the different types of services provided by the operating system. Okay, and the hardware is at the lowermost, means this all interact with the hardware for performing the operation. Next we have is the operating system, user operating system interface. Okay, so user can have two options, either go with the command interpreter or use the GUI. This is the command line interface, where we'll be executing the commands in the command line. GUI is the icons which will be user friendly, and we'll be clicking it, easily understandable what we have to do. So for the new users, we'll be using GUI. They will be using GUI. If it's a professional software developer, they will be using command interpreter, because it's more faster. It will not take time to load the images and so on, right? So next topic we have is the system calls and its types. What is system calls? System call is nothing but in the previous diagram, as you can see, the system call means when we the users do some operation, we will be calling either of these services, right? So that calling of the services is called system calls. Okay, so what is system call and its different types? So a system call, you have understood, we are trying to call a function of the system for performing some operation, and this is the user. And suppose that I call the function open. Okay, so this is the user mode. After this point, it goes into the kernel mode. In the kernel mode, there is a function defined open, which does this operation here and implements the open, and then sends back the result to the user. So this is happening internally. This is the kernel and this is the user point of view. Okay, so this is called as a system call, and for this we'll be using APIs as well, if it's in a different location and different servers and located in different environments. So API, what it will do, it will be just specifying what operation we want to perform. It will do the operation and give back the result. So all we can see is we gave an operation, we got the result. We don't know how it is working. Okay, that is called as API, application programming interface. From this interface, it will hide the details from us, and it will just give the result to us. Okay, So there are 6 types of system calls. The first is the process control. What are the different kinds of process? Ending and aborting, loading or executing a process, creation of the process, termination, getting the attributes, and waiting for the time, waiting for event or signal element, allocating free memory. And next we have is a file management: creation, deletion, open, close, read, write, reposition, and get file attributes, set file attributes. Next we have is the device management: request device or release device, read, write, reposition. And logically attached or detached devices means all the operations related to devices are being performed by device management. Next we have is the information management. Here we'll get the time and date, all the data, which is how much data it is, like size of the file, system data, and the processes attached, and what are the device attributes, getting or setting, both. Okay. And communication means creation and deleting communication connection, sending, receiving messages, transfer status information, attaching or detaching remote devices. The last one we have is the protection: access is granted or not, privileges is given to that specific user or not, that checks will be performed, and is the user being in the user mode or in the kernel mode, that check will also be performed here. Next we have is the system program. What do you mean by system program? It is a collection of programs. Okay, what is system program? It is a collection of programs for the execution of processes is called system programs. Means we'll be performing some operations. Like for example, for the file management, we need to have an interface where we can view the file, edit the file, save the file, and check the history of the files. Those applications are called as system programs. Status information: we'll be able to see all the status of every file and the data which are present in the system, and even the devices which are present, all those information which device gives, those are the status information. Next we have the file modification. For modifying the file, what are the apps we'll be using, that is the another system program. And programming language support: to execute a program, to write a program, that a framework should be present, right? The compiler and all, and the interface, those are the programming language support. Program loading and extension: here we'll be using the constant and the loaders and the linkers, those things will be present here to enhance the, like, to facilitate the program loading and execution. Next we have is the communication. The connection category should be present. We should be able to make a connection with the different system for transferring the data, such as there should be an option for the Bluetooth or via USB wired device. All those things come under system programs. These are predefined by the developer so that these operations can be performed easily. Okay. Next we have operating system design and implementation. Suppose that you want to make your own operating system. What all things you need to keep in mind? Design goals: what are the user requirements and the system requirements? Based on this only the design will be made. Mechanisms and policy should be defined: what we have to do and how it is to be done. Mechanism is related to what is to be done, and policy means how it is to be done. And implementation: choosing the framework and programming language for developing the operating system. Okay. Now we have the next topic, which is operating system structure. There are 4 types. The first is the simple structure. Here we'll be having a very basic level. It cannot store data for a longer time, and it has many more disadvantages. This is the first type of structure, which is simple structure. Here we have the application program connected with a resident system program, and MS-DOS device drivers are present, which are connected with the most internal ROM BIOS device drivers. Okay, so it is interconnected, and this is a simple structure for performing very small tasks. Okay. Next is the layered approach. Here we'll be having layers. So each layer we can access one by one only. Okay. So in this way, the approach is made for the operating system, that is layered approach. Next is the microkernels. For each operation, we'll be having one kernel assigned called as microkernel, which will handle the inter-process communication, memory management, and CPU scheduling. And this will be connected with the program, system, file system, and device drivers. This is called the user mode, and this is called the kernel mode. And this will internally interact with the hardware. Okay. Next we have the modules. Different modules will be defined which can be linked with each other for the performance of the operation. So these are developed separately, and whenever we want, we can choose whichever is our requirement and interconnect it with the main kernel and then use it. This type of operating system is called as module based operating system. Next we have the virtual machines, VM. Okay, what it is? It is abstracting the hardware of a single computer into various environments. See, there is one computer divided into various environments so that each environment will look like a different environment. Okay, that is called as a virtual machine. So here this is the normal computer. We have processors, kernel, and hardware. Here we have divided the processors and the kernel and the hardware into 3 categories so that it looks like this is a separate computer, this is a separate computer, and this is a separate computer. It has its own advantages where we different requirements are different to be run parallelly and to save some resources, to share the memory along with each other. So this if the requirements arise, we will be going with the virtual memory. Okay. Real life examples include are VMware and Java VM. The last topic of the module is the operating system generation. Okay, operating system generation is how does operating system get generated? It must be able to run on any site of the computer. Whatever the operating system is there, it should be able to run any site of the computer. And how the operating system gets generated? By sysgen. Okay, sysgen is a function which will fetch the information of the operating system by running a bootstrap program. So what's happening here? When we switch on the computer, at that time a function will run which is called the bootstrap program. It will fetch all the information, which includes the sysgen information, and it will be able to check if it can run on any sort of the computer or not, as well as to on the computer a piece of code is required. That piece of code will have the information to start the execution of the program or the system itself. That is called as a bootstrap loader. Inside the bootstrap loader, it will execute the boot block which will have the required information for starting the computer system. That functionality is called as system boot. Okay, that's the first thing which happens when we turn on this computer. Okay, and this will fetch the sysgen information, which then further checks if it is able to run on any side of the computer or not. Okay, so that's all for this video. Make sure you hit the like button, subscribe to my channel for more videos like this. If you find this video helpful, please do like and subscribe. And thank you so much for watching. I'll see you in the next one.